Morning, year six. This morning, we're going to continue with our lessons that we started last week on ratio. It's going to be talking a little bit about the mathematics side of ratio and proportion today. But I just wanted to get our minds focused on what ratio is and how it calculates by referring back to a couple of things that we've worked on with fractions. Now, one of the things that you'll need to remember from our fractions learning from the first term is lowest terms and equivalent fractions, and you'll see why soon in this video. So if you remember with equivalent fractions, we were given a fraction. In this case, we've got 12 over 40, and we need to bring that down to its lowest terms. We need to reduce that fraction. And in order to do that, we would find its highest common factor. In other words, the biggest number that can divide into both 12 and 40 without leaving a remainder. And in this case, the 4 times table, or the number 4, is related to both 12 and 40. Now, we could use the number 2. However, that wouldn't give us the lowest term. You'd find that you'd have another step of reduction to do. We couldn't use 6 because in this case, yes, 6 is related to 12, but 6 is not related to 40. So once we've done our reduction, you'll see that our lowest terms here of 12 over 40 comes down to 3/10. And if you remember, I said to you, if you want to make sure that you are at lowest terms and you cannot reduce a fraction anymore, you just need to either look for a prime number in that fraction, the numerator or denominator, or look for an even number and an odd number. And that will basically tell you that you're at lowest terms, because you will not find any relationships if one of the numbers is a prime number or if there's an even number and an odd number. If you look at the second example here, you've got 25 over 45. And again, we want to look for the highest common factor. In other words, what is the biggest number that can divide into both 25 and 45 without leaving a remainder? With your knowledge of tables, you'll quickly see that the obvious number here is going to be 5. It is the largest number that can go into both of those without leaving a remainder. 25 divided by 5 gives you 5. 45 divided by 5 gives you 9. And you'll see that equivalent fractions is a skill that we will be using when we are talking about ratios. So just like fractions, when we spoke about fractions being a comparison of how something has been divided into pieces, and more often than not, you're looking at a comparison and a commonality or common denominator in what you were comparing. Ratios tend to do that in a different way. And how they do that is by using proportion. It's unequal sharing. And by unequal sharing, it means that when you're given a specific amount of something and you're sharing it between 2 people or 3 people or 10 people or however many people, it's not going to be everybody in that group getting an equal amount. So when we were dealing with fractions and we were looking at how, let's say, we were going to share our pizza, we would have our pizza. Let's say we're sharing this between 4 people and we're sharing it equally. We know that each person is going to get 1 of these 4 pieces of pizza. However, when we are sharing ratio, it does not necessarily mean that each person is going to get 1 of these pieces of pizza. So if we were sharing this with 2 people, each person is going to get 2 times a quarter or a half of the pizza. Now, if we're sharing the same thing, this pizza here, with 2 people again, but we were using the ratio of 1:2. That does not necessarily mean as a fraction, it would mean each person is getting a half. No, it would mean that the first person, and remember, I've said to you before that order matters. So if this person here that I'll just highlight them with green, and this next person I'll highlight them with pink. What it means is that the person in green is going to get one piece of pizza, and the person in red is going to get 2 pieces of pizza. Now, why this works is because you now start applying proportion to this. Now, if I had to continue dividing this pizza up, in this case here, it's easy to see that this person here would get 1 piece of pizza. Now, let me make that a bit bigger. The person in green would get this piece of pizza here, and the person in pink would get this piece, these 2 pieces here, because if green is getting 1 piece, that means when we share the next round, the next person needs to get 2 pieces. And you'll see that we now have 1 piece left over. And we can't share that out to anybody because we are sharing according to a given ratio. Now, you could do this very often in your families. The older person tends to get the bigger share and the younger sibling in the family gets a smaller share. You guys are sharing stuff, but again, that is not equal sharing. So even though you're not calculating it, you are sharing proportionally. I'm bigger than you. If I'm twice your size, I should get twice the amount of food. You are half my size. You should get half the amount of food. For every 2 shares that I get, you get 1 share. So if I'm the pink, every 2 shares I get, you the green, you get 1 share. Now, the way ratio works is that we can continue to apply the same idea proportionally. So what that means is if I continue to divide this pizza up, and let's say I make it into 8 pieces. Oh, that's a very skinny piece. Make it a bit fatter. Yeah. And I make it into 8 pieces. Now, they don't have to be perfect pieces, okay? Now, it doesn't mean that each person is still going to get half, because you'd get 1, 2, 3, 4 eighths, 1, 2, 3, 4 eighths. Each person is getting half if you were sharing equally. But with ratio, you are not sharing equally. We are still going to apply our given ratio. So for every 1 piece that the green person gets, or in this case you, I'm going to get 2 pieces because our ratio is 1 to 2. So I'm going to get 2 pieces of pizza, and I'll shade them in here. And then we go back to our next round of sharing. I'm going to get 1 piece of pizza. I've now got 2 pieces. Guess what that means? You need double what I'm going to get, which straight away means you're going to get the next 2 pieces of pizza. And again, if you look, we now have got 2 pieces left over. And what do we do with these 2 pieces of pizza? We cannot share them out because there is not enough for us to each get our total share. There's not enough for you to get 1 and for me to get 2. So basically these would be left over. And in this ratio from this piece of pizza, you would get 2 pieces and I would get 4. You would get 2 pieces. And let me use the same color so that I don't mix you up. You would get 2 pieces and I would get 4 pieces. Now, the reason why I showed you the introduction with equivalent fractions is because we started off with the ratio of 1 is to 2. Oh wait, 1 is to 2, not 2 is to 2. And if you think about it, knowing equivalent fractions, is 1/2 equal to 2/4? Yes, it is. We can see that 1/2 is half of 2/4, or 2/4 is twice the size of a half. Now, what is important is when we're talking about a ratio, we need to understand that in our round of sharing, we're not just going to divide all of my parts first and then give you the remainders. There's something that is called a total share. And this is where ratios moves away from fractions. When we look at a fraction and we see the denominator here, we know that that's telling you how many parts our whole has been divided into. But when we look at a ratio, we look at the entire ratio as 1. This is what we call the total share. Basically, that means when I give you one piece and I take my 2 pieces, 3 things have been shared. When you get your 2 pieces and I get my 4 pieces, 6 things have been shared. But you can see there's a proportion between the number 3 and 6. 6 has doubled. You can see there's a proportion between 2 and 4. 4 has doubled. You can see there's a proportion between 1 and 2. 2 has doubled 1. And this is how ratio and proportion now begin to fit hand in hand when we look at them mathematically. I can explain it to you in a different way. Here I've got a whole bunch of red and blue counters. And if we were to share these equally, it would be a matter of, we could either decide, well, let's see how many blues there are, let's see how many reds there are, and we divide this between myself and you. The problem is there might be leftovers. So let's actually count. We've got 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, here's the 10th one hiding here. 10. We've got 10 red, and we have got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We have got 10 red, and we have got 20 blue. There, that might help that you're not facing upside down. So already we can see that we have got a ratio. We have got a ratio of 10 red counters for 20 blue counters. But let's break it down. If we had to divide this by 10, that would mean that we have got a ratio of 1, 2. Proportionally, we've just divided by 10. But do we have the same amount of counters on the desk here? No, we don't. Proportionally, do we have the same number of counters on the desk? Yes, we do. We have got 1 red counter for every 2 blue counters. So what that would mean is that my total share here is 3. I'll just make a little column here. Total share. Total share is 3. If I had to add another red counter for my 1, how many blue counters would I need to add to keep the proportion the same? Correct. I would have to add another 2 blue counters, which brings my total share to 4 plus 2. I've now got 2 red to 4 blue. My total share is now 6. And we can just keep going, never stops. If I add another 2 red, another 1 red, okay? That means I need to add another 2 blue. I've now got 3 red, and without having to count, we basically understand that we're doubling according to our proportion. That should be 6 blue without having to count them. And my total share is now 9. Now I want you to see what's happening here. We've got a number pattern. We started off with 10 red and 20 blue, but we've got a number pattern 1, 2, 3. We'll continue with our prediction. 4, 5, 6. And we'll continue with our prediction here. We've got 2, 4, 6. So I'm guessing it will continue 8, 10, 12. And our total share, if we look at our number pattern here, 3, 6, 9. I'm presuming it's going to continue proportionally 3, 6, 9, 12, 15, 18. You can see that in this simple ratio, there is a number pattern that begins to emerge. We have got in this case, we had 2 reds for 4 blue and a total of 6 counters on the table. We had 3 reds and 6 blue and a total of 9 counters on the table. And so on and so forth. If we were to write these as a fraction, however, we would not write this fraction as 2 out of 4. Because for every single one of these ratios, you could write 2 fractions. And this is what you could write. For this first one here, you could write 1 over 3, or 2 out of 3. That's for this one here. And the reason why it's out of 3, it's because that's your total share. That's how many parts this round of sharing has been divided into. So it wouldn't, your denominator wouldn't be 2, or it wouldn't be 1. It would be 3, because that is your total share. That is what it has been divided into. Let's take this one. If I had to write my ratio for the red counters, I would say that there are 3 out of 9 counters that are red, or I could say that there are 6, oh sorry, wrong color, that there are 6 out of 9 counters that are blue. Again, my denominator doesn't come from the fact that it's 3 over 6 or 6 over 3. Remember, this is the round of sharing that we've done, but we can only share 3 for me and 6 for you if we had 9 counters to begin with. So if we didn't have this denominator in this case, we wouldn't be able to complete the round of sharing. So now if we come back to the start where we had our 10 red and 20 blue, if we had to continue this proportion of 1:2, and if I had to say to you, this is the proportion we started with, the ratio that we started with, 1 red for every 2 blue. And if I said to you now, I want to now have, I've got 10 red counters here, but I want to now have 12 red counters. How many blues do you think I should have? If you think about the proportion, the blues have been basically twice the number of reds, or in reverse, the reds have been half the number of blues. So if I'm given 12 red counters, I'm adding another 2, so I've got 12 red. How many blues should I end off with? According to my ratio, if my blues are always supposed to be proportionally twice the number of my reds, I should have 24 blue counters. And that would look something like that. Okay? Feel free to count them if you really want to. So this basically brings us back to where we started here. When we're looking at a certain type of sharing that is unequal, but it is fair because it's showing something in proportion. And to just put this into a little bit more of a real world scenario, you can have a number of people sharing a certain number of pizzas, and you can divide those pizzas so that every person gets an equal amount, or you can just share them proportionally. Here, you've got one person eating 4 pizzas. Here, you've got 4 people eating 1 pizza. And you can see that order matters here. In this case, the person is listed first, and that's the ratio 1. In this case, the people are listed first, but to the ratio of 4. In this case, you have got 1/4 the number of people to the number of pizzas. In this case here, you have got 4 times the number of people to the number of pizzas. You are sharing totally, in each case here, you're sharing 5 times. Here you're sharing 1 pizza with 4 people. The total share is going to be out of 5, okay? And in this case here, you've also got your 1 person sharing 4 pizzas. But you can see that there's no equality here. Proportionally, yes, they might all get fed, but are they getting the same amount each? Absolutely not. Have a look at this picture here. The proportion given here is lions to birds. Now remember, order matters. So that means if the proportion is lions to birds, you need to list the number of lions first and then the number of birds second in your ratio. And that is why the ratio's order matters. If I say lions to birds and I say 6:1, that automatically locks the number 6 to lions and the number 1 to birds. If I said lions to birds and I wrote a ratio of 1 to 6. That would be totally wrong because there's not one lion here and there are not 6. So I'm going to just leave this with you for today, and I'm going to give you a couple of easy exercises to practice with writing ratios and bringing ratios down to their lowest terms. Please feel free to contact me if you need an extra explanation or if you need some help. And then next week we can go into the calculations of using the ratios and how to actually calculate the sharing of a given amount. You don't have to do what we did here with the counters, and you don't have to do 1 for me, 2 for you, 1 for me, 2 for you, and share it out piece by piece like that. It's very possible to use multiplications of fractions, fractions of a whole, or even percentages, because percentages, remember we spoke about percentages as being a type of proportion. And I'll show you how it's very easy to use the skills that you've already learned to calculate what each person would get according to a given ratio. I hope you've enjoyed this lesson. I hope that it's made sense to you. It's a bit of a tricky one to understand, but the calculations, I promise you, will be very easy and straightforward. Let me know what you think, and I hope that you will get hold of me if you need help. Have a nice day.